Evening friends, and in this video we're going to discuss about the logarithm. Logarithm is a very important mathematical concept, and it is based actually on indices. Like indices means a number raised to another number gives you a number like 2 to the power 3 is 8, or 10 to the power 3 is 1000, etc. So indices is the beginning. So indices, so just before starting the definition of the logarithm, I will brief you a little about the indices, simply in terms of the formulas. Then indices, you know that the a to the power m means a has been multiplied m times. So it goes like a into a, like that, m times. So a to the power m is n, then a to the power n is a into a, that is n times. Now just assume that m is greater than n. So if I multiply these two, a to the power m into a to the power n, I get a to the power m into a to the power n. So it will become the m times here and the n times here. This will become a to the power m plus n. This a will be multiplied m plus n times. So we can write this as a to the power m plus n. So this one is a formula. Then we use, like suppose if I divide this by this, a to the power m over a to the power n. This one will be like, if I put divide here, then some a's will cancel, and the difference, like the m minus n, will be left. So the second formula goes like a to the power m divided by a to the power n is a to the power m minus n. Then next formula is a to the power m whole to the power n, and this simply becomes a to the power mn. Then we have any number to the power 0 is 1, and then we have one formula. This is nth root of a is a to the power 1 by n, and then one more, that is a to the power minus m is 1 upon a to the power m. So these are the formulas of indices. If anybody interested, if they want to make a note of it, then you can halt the screen and you can copy it down. So we have one formula here, 2, 3, 4, 5, and this is last 6. So these are the ideas of the logarithm. Now indices, these are called indices, and the logarithm is defined on the basis of these indices. So just give me a 5 seconds break, and then I come back to you after removing this. So now here we are defining our logarithm. So the logarithm says that if you have a number, if a to the power x equals n. So if a is multiplied x times and you get n, then log n to the base a is x. This is the basic definition of logarithm. So if a to the power x is n, then the log of n to the base a. So a is the base of this indices. So the base remains same. Base of the indices is, this is a, and the base of the logarithm is also a. What was exponent here, that becomes the value, and what was the value here, that becomes the argument of this logarithm function. But the condition here is that a should be greater than 0, as well as a should not be equal to 1. This is the restriction. Now on the basis of this restriction, if you see that if you have a positive number here a, and on this number if you raise something x, so you can write anything, like suppose if I have a positive number 5 and x is a rational number, so if it is -7, or if in another case it can be 3, or I take one more 5 to the power 0. So three situations I am taking. So if I take this situation, then what I get, that this one is written as 1. So what you see, that this one is written as log 1 to the base 5 is 0. What does this suggest? That whatever is the base, log 1 is always 0. Like if I write p to the base 0, p can be anything, because indices says that any number to the power 0 is 1. So log 1 for any base is always 0. Now here you see that I'll get -7 is, sorry, instead of this I use 5 to the power 3. If I write as 125, so I get log 125 to the base 5 is 3. And here 5 to the power -7, if I say this is x, because this is 1 upon 5 to the power 7, 5 to the power 2 is 25, 3 is 125, 4 is 625, then 7 is 3125, 6 times is 156,525. But I'm not going to this, because this definitely this is going to give you a number. I consider this number as, so I will have my log x to the base 5 is -7. So now in all these cases you see your argument is also greater than 0. So we can say that n here is also greater than 0. This n. So we have two restriction, log n to the base a. Like if a to the power x is n, then the log n to the base a is x, where a is greater than 0, a is not equal to 1. So a is a positive number other than 1, and n is a positive number, and then this one gives you the idea of the logarithm. Now based on these definitions, there are certain formulas which I would like to write. So first just have to clean this screen. So just give me again. Okay, so I write some formulas. This is formula 1, and it goes like log m into n, and the base for this is a. So log product of two numbers, and the log convert this into the summation. This becomes log a, log m to the base a plus log n to the base a. Number 2, log converts division into subtraction. So log m over n is, okay, let me write in order. So log m to the base a minus log n to the base a. Then third, log base is m, a, and this is m to the power n. So this one becomes n log m, and the base remains same, a. Now number 4, log 1 for any base is 0. Then I write other formulas here. Number 5, log a to the base a is 1. Means when, so if you see, if I try to convert this a to the power 1 is a. So when the log, this argument and the base remains same, then that value becomes 1. Number 6 is log m to the base a is 1 upon log a to the base m. So if you reciprocal a logarithm term, then the base and argument just interchange each other. And third category is called as change of base. Change of base. Like if you are interested in changing the base, then suppose you are given log m, and the base given is a. Now I want my base to become b, another number. Then how can I do? Just write log m to the base b upon. So log m to the base a. This is the given base, and I'm changing my base to b. So just write as it is, just log m upon base, like log m to the base b, and then upon here you can write log old base is the argument, and this also b. But if you see this formula properly, then here if you see log, if it's reciprocal, so 1 upon this, so this will become log b to the base a. So log b to the base a and multiplied with this. Now log m to the base b. So look, it's becoming like a chain. A, B, B, M, and A, M. So just like B and B, they are cancelling each other. It is just up to you how you take this home. If you can by heart this formula is fine. If you understand, there is nothing more to understand. It is just logically written here, m to the base a, and this you can write like a starting from this given base, and then I want to change to new base, so log a to the, so this is log old base, no, this is log old base, so log b to the base a into log m to the base b. Now this is up to you how you see, like if I say the log old base and this is new base, so I say log new base to the base old base into log m to the base new base. So just like this, or the main definition is this one. Now, how to prove these relations? Nobody going to ask you how to prove this relation, but if you are interested, one I am just trying to explain you. But before that, I have to clear this mess. So just give me another. Trying to prove this first formula, which says that log a m into n, or you can say the suitable way of reading it is like goes like this: log m into n to the base a is log m to the base a plus log n to the base a. So I assume this one is x and this is y, and I can say this is z. So if you just take this in this form, so what I'm getting log m to the base a, just like this. Log m to the base a is x. Now, since if this definition gives you the birth of logarithm, then from here I can return back any time to the indices. So what I'll get, m m m is a to the power x. So same way here you get m is a to the power x and n is a to the power y. Now what is m into n? So m into n is a to the power x into a to the power y. So this becomes a to the power x plus y. This is m into n. Now convert this into the logarithm again using the same relations. A to the power x plus y is n. So this is your whole is n. So what you get? You get x plus y is log m cross n to the base a. So this is x. Now you see this is x plus y, and x plus y is equal to this. Then here we got the proof that log m into n to the base a is log m to the base a plus log n to the base a. This is all about logarithm. So about the other important features of logarithm, we'll go into our next video because it's unnecessarily becoming very long. Thank you very much. Subscribe to our channel and keep practicing with us. And if you have any suggestions, then please write in the comment section so that we can make some modifications to the videos, or so that you can really comply it with properly. Thank you very much. Have